Welcome to section 5.6. In this section, we're going to talk about dividing polynomials. Now, objective number 1 is just how to divide a polynomial by a monomial. When you are doing this, it's very straightforward. You're just going to take that polynomial in your numerator, and you are going to divide each term separately by the monomial. So just an important thing to remember your denominator cannot be 0. All right, so here's your first example. So we are going to take that polynomial of 3 terms. We've got a trinomial. We're going to divide it by 3a. So we're going to rewrite this. We're going to take each term in the numerator and divide it by 3a. Plus 36a, divide that by 3a, minus 15, divide that by 3a. Okay, so just break it into 3 small division problems. And then you're going to simplify each of these problems using all of the exponent rules that we talked about earlier in this chapter. All right, so negative 12 divided by 3 is negative 4. A cubed divided by a, we're going to use the quotient rule and keep the base and subtract our exponents. Next up, 36 divided by 3 is 12. And then the a's, notice the a's will divide out completely, so we don't even have to worry about the a's at all. Minus. Now, I don't know why this is, but it's usually the last term where people make a mistake. So I caution you to just take some extra time with this term. Personally, I like to set it up like a fraction. Like I did simplified fractions. 15 and 3 share a factor of 3. So 15 is 3 times 5, and 3a is 3 times a. Notice the 3's will divide out, and I'm left with 5 over a. So this last term is 5 over a. Okay, so that is my final answer. Your homework may or may not ask you about your answer. It may ask you, is this a polynomial? All right, is this a polynomial? And the answer is no, it is not. Even my dog, who is panting behind me right now, can tell you this is not a polynomial because of this last term. Okay, because of this. That is a big no. Remember, a polynomial cannot have a variable in the denominator. Okay, it cannot have any negative exponents. So no a's or x's or anything like that in the denominator. So this answer is not a polynomial. It has 3 terms, but it is not a trinomial. Remember, a trinomial is very specific. It is a polynomial with 3 terms. So this is just an expression with 3 terms, nothing more. All right, why don't you give this one a try if you want to press pause and give it a shot. All right, welcome back. Let's see if your work and my work are going to match up. So I'm going to take each of these terms in the numerator and divide them by 3xy. Go to the next one, divide that by 3xy, and then do the last one and divide that by 3xy. All right, so 12 divided by 3 is 4. X squared divided by x is x squared. Y cubed divided by y is y squared. Minus. 18 divided by 3 is 6. The x's will divide out and the y's will divide out. Plus. All right, and again, if you struggle with this last term, I do it very old school and go right back to fractions. So 6 is 2 times 3. So 2 times 3 times y is my numerator, and my denominator is 3 times x times y. So notice the 3's will divide out, notice the y's will divide out, and I'm left with 2 over x. So 2 over x. So there's my final answer. Is that a polynomial? It is not, because of that last term. Okay, this is not a polynomial. You cannot have a variable in your denominator. So it may turn out that it comes out perfect and you don't have any variables in your denominator. That'd be great. Then it is a polynomial, but every problem is going to be different. So please make sure that you're being extra careful on these. All right, so that is objective number 1. Objective number 2 is when we are going to divide by a polynomial. So in order to do this, we're going to need to talk about long division. And long division is probably something that you have not thought about in a very long time. So the first thing I want to do is just recap long division, just to give you an idea of what you're going to be doing when you're dividing polynomials. And it's very similar. We are actually going to use long division to do this, so it's kind of cool. Okay, so let's just do some basic math here. Okay, so think way back to your elementary school days. All right, when you were doing long division. So 43 does not go into 7. Does 43 go into 42? Yes, it does, but it only goes in one time. So I'm going to put a 1 here. And then I'm going to multiply 1 times 43, which would give me 43. And then I'm going to subtract and bring down what's left. So 72 minus 43 is 29. So I get 29. 43 does not go into 29, so I'm going to bring down the next unit, which is the 5, and then repeat this process. How many times does 43 go into 295? So if you take 295, divide that by 43, it's 6.8. So I know it goes in there 6 times. So 6 times 43. 6 times 43 is 258. So I'm going to put the 258 right here. I'm going to subtract that again. So 295 minus 258 is 37. 43 does not go into 37, which is good. We're going to bring down the 6. Okay, 376. Does 43 go into that? Yes, it does. It goes in 8.7 times, so I know it goes in there at least 8 times. So 8 times 43 is 344. And then I'm going to subtract that. So 376 minus 344 is 32. So I have a remainder of 32. Now, how you write your remainder is going to be a little different than you did in elementary school, though. So your answer is 168, and we do have a remainder. So you're always going to write your answer as remainder over denominator. So you should always check to see if this is going to be, if you can simplify this fraction. In this case, we can't because 43 is prime. So, but yeah, so just some verbiage here. This answer right here, this is your quotient. Okay, we had a remainder, which is fine. Okay, the number we are dividing by, this number is called the divisor. And the number that we were dividing, that's underneath the little house here, that is called the dividend. Okay, so these are all words that you should kind of remember from elementary school, and I know that was a really, really long time ago. So that's a divisor, by the way. It's an R, not an N. Okay, so we've got the dividend. That's what it started with. We divided it by the divisor. We got a quotient, and then there possibly could be a remainder. So remember, when you write your answer, it's quotient, and then remainder divided by divisor. So if you do need to practice some long division with just numbers, I would highly recommend that you do that. Just go on YouTube, type in, okay, long division, and like 28,000 videos will pop up. So go ahead and go do some work with that first before you continue on with this section. But again, the technique is pretty much the same. You divide, you multiply that number by the divisor, you write that down, then you do the subtraction, and then you bring down the next step. So it's very repetitive when you do long division. And we are going to do the same thing when we're dividing polynomials. We are going to do long division. There are a couple of tweaks, though, that you have to make sure you're aware of. So we will talk about those as we go through the examples. All right, so here's the first example. The first thing you want to make sure is that you have all of the terms in order here. So x squared, x, and then no x, which is good. Notice every single one is, we're not missing anything. If we are missing anything, we'll talk about that in a second, what to do if you're missing a term. All right, but we have those, and same thing here in your divisor. Definitely we've got the x and then no x, so we're good. Okay, so we are going to do the same thing, but really all you have to focus on is the leading terms. So the 7x. Does 7x go into 28x squared? Yes, it does. 7 goes into 28 4 times, and x goes into x squared, right? You do the division, like 28 divided by 7 is 4, x squared divided by x is x. So 4x times 7x is going to give us 28x squared. But then you also have to multiply it by this one here. So plus 12x, right? 4x times 3. And then you're going to subtract all of that. And this is usually where bad things happen with most people, because you're subtracting everything. So 28x squared minus 28x squared should give you nothing. That first term should always fall away. Then you're going to do negative 23x minus 12, which is negative 35x. And then you're going to bring down the next term. And then you're going to repeat this process. 7x times what would give me negative 35x? And that would be negative 5. So negative 5 times 7x would give me the negative 35x that I'm looking for. Negative 5 times positive 3 is oops, not positive. Hello, where's my eraser? green. All right, so negative 5 times positive 3 is negative 15x. And again, you're going to go back and you're going to subtract all that stuff. So subtracting a negative, this becomes adding, subtracting a negative, that becomes adding. So this actually becomes an addition problem. So these go away, and notice these go away, I have no remainder. So that way my answer I know is 4x minus 5. If you want to check if these are correct, the great thing is if you take the quotient times the divisor, you should end up with the dividend if you had no remainder. So if I take 4x minus 5, and I multiply it by 7x plus 3, I should end up, if I FOIL this out, I'm going to end up with 28x squared plus 12x minus 35x minus 15. Combine those like terms in the middle. 12, positive 12 minus 35 is negative 23. So if you look, voila, you get the dividend. So this is your check. Okay, so if you want to check and there's no remainder, it's just quotient times divisor should give you the dividend. So you could, the nice thing about these is you can double check them, which is always good. All right, let's try another one. All right, same kind of problem. I'm going to start again. All right, 2x times what would give me 4x squared? That would be 2x. So 2x times 2x is 4x squared. 2x times positive 7 is positive 14x. Right, we're going to subtract all that stuff. And that gives me that 4x squareds will subtract, which is fine. Negative 6x minus 14x would give me negative 20x. And then we're going to bring down the plus 8. Right, and then do this again. 2x times what would give me negative 10? So that would give me negative 10, right? Negative 10 times 2x gives me the negative 20x. And then negative 10 times 7 is negative 70. Then we're going to subtract all that stuff. So the x's go away. 8 minus negative 70 is addition, right? Subtracting a negative would be adding. Subtracting a negative would be adding. So that's positive 78. So this one has a remainder. So we're going to add 78 over 2x plus 7. All right, so there would be my final answer. Now you can check this as well, but the check's going to be a little bit different. So this time you're going to do the quotient times the divisor, but then you're going to add the remainder at the end. So my quotient was 2x minus 10 times the divisor, which was 2x plus 7, and then we're going to add the remainder at the end. So let's see if this all works out. So when we do all this, it should add up to that dividend, to the dividend right there. So FOIL, I get 4x squared plus 14x minus 20x minus 70 plus 78. So I've got like terms here and I've got like terms here. So 4x squared minus 6x plus 8. Look at that. We get the dividend all over again. So that is my check. I've double checked it. I know it works, so I'm good to go. So make sure that you're checking your work as you go along. It's also a nice thing to know that you can check. All right. Here's a little bit longer one. Maybe you want to try this one on your own. Press pause, see how you do. Welcome back. All right, let's see how we did. All right, so x times x squared would give me x cubed. So x squared times x is x cubed minus 7x squared. I'm going to use a different color for subtraction. There we go. Subtract all that. Those go away. Negative 13x squared minus a negative is adding. So negative 13 plus 7x would give me minus 6x squared. And then I'm going to bring down the positive 40x. So x times negative 6x, so this would be minus 6x. So negative 6x times x gives me the negative 6x squared. Negative 6x times negative 7 is positive 42. I'm going to subtract all that stuff. So subtracting a negative is adding the 6x squared, so that'll go away. And then 40 minus 42 would give me negative 2x. And then I'm going to bring down the positive 14. So x times negative 2 would give me that negative 2x. So negative 2 is going to go here. Negative 2 times x is negative 2x. Negative 2 times negative 7 is positive 14. I'm going to subtract all that, and that's all going to go away. So I have no remainder. So this one was rather nice. My quotient came out to be something very nice and pretty. So let's double check it. So if you're going to do the check, you're going to multiply your quotient times your divisor, and then we don't have to add on any remainder because we didn't have one. So this is just a matter of a big multiplication problem. So if I'm going to take the x times all that stuff first, and then I'm going to take the negative 7 times all that stuff, let's see what happens. So I get x cubed minus 6x squared minus 2x minus 7x squared plus 42x plus 14. So let's see, I've got an x cubed, x squareds, I've got x squareds here and I've got x squareds here. Negative 6 and a negative 7 gives me negative 13x squared. Then I go to my x's next. I've got negative 2x and a positive 42x, which gives me positive 40x. And then the number all by itself doesn't have any partners, so positive 14, which lo and behold, that is my dividend, so I am good to go. So again, check, check, double check everything. Make sure that you have double checked all of your answers before you put your final answer in the homework. All right, now let's talk about what happens when there's a term that's missing. So far, everything has been lovely. All the terms were all represented. But if you look at the dividend that's presented to you here, notice it is missing a term. We've got the x cubed, but we do not have an x squared. So what you need to do is put a placeholder. So you're going to put plus 0x squared, because there is no x squared in this problem, and then minus 2x, and then plus 2. So you may need to put in a placeholder. That is a definite possibility. And then we're going to divide by x plus 1. So don't be afraid of those placeholders. You may need a placeholder in your dividend. You may need it in your divisor. It all depends. All right, so let's walk through this problem. So x times x squared would give me that x cubed. And then I'm going to subtract all that. Makes those go away, which is fine. And then I get, let's see, 0 minus x squared would give me negative x squared. And then I'm going to bring down the negative 2x. So this times a negative x would give me negative x squared. So negative x times x is negative x squared. Negative x times 1 is negative x. All right, I'm going to subtract all those. So the x squareds will go away because I have a negative x plus. Remember, this will be addition, and then this and this will also be addition. So negative 2x plus x is negative x. And then bring down the 2. So x to this would be negative 1. So boom, boom, negative x. And then negative 1 times positive 1 is negative 1. I'm going to subtract all that stuff. The x's will go away, and then I get 2 minus negative 1. Again, that's still adding, so 2 plus 1 would be 3. So I have a remainder of 3 this time. So plus 3 over my divisor. All right, so there's my answer. And then just in the investment of time, okay, so you guys know how to check. You take this quotient, multiply it by this divisor, and then you're going to add your remainder. So if you want to, you can multiply that out, double check, make sure it works. But just for the interest of time for this video, I will not do the check on that problem. All right, so here's one for you to try. All right, so if you want to press pause and give it a shot. All right, welcome back. First thing I'm going to do is work on this setup. So here's my divisor, my dividend, sorry. I notice I'm missing a term, so x to the 4th plus 0x cubed minus 10x squared minus 2x plus 4. So make sure that you have that placeholder that you're missing. And then my divisor is x plus 3. All right, so then I'm going to go to town. So here we go. We're going to start with x cubed. X cubed times x is x to the 4th plus 3x squared, 3x cubed. We're going to subtract all that. And I'm going to get negative 3x cubed. Bring down my next term and go again. X to negative 3x cubed is negative 3x squared. So that would give me the negative 3x cubed. And then this would give me minus 9x squared. And I had a student that once told me, like, instead of doing the subtraction sign like this, he just said I just changed these signs. So this would become positive and this would become positive, which is another way you could do it. If you like it that way, just change the signs as you go along. Both are equally valid forms. All right, next one would give me, that would be a negative x. So negative x times x would give me negative x squared, and then negative x times 3 would give me negative 3x. And then change the signs. That would become positive, that would become positive. Those go away, and then that would give me positive x, and then bring down the plus 4. So x times 1 would give me the x, and then 3 times x is plus 3. And then again, I'm going to subtract those. Subtract, subtract. X's go away, and I get a remainder of 1. So plus 1 over my divisor, sorry. So there is my final answer. And again, if you would like to check, please do so. Quotient times divisor, and then add that remainder of 1. And you should end up with your dividend. So don't be afraid to check these problems as you're going through. It is very time consuming, but it works. All right, so again, just to remember, when you're checking long division, you have your two options. Remember, it's divisor times quotient plus a remainder if you have any. So like this last problem, let's just do the check on that last problem. Here was my divisor, here was my quotient, here was my remainder. Okay, so you can multiply this out. So I'm going to take x times all this stuff first, which would give me x to the 4th minus 3x cubed minus x squared plus x. And then I'm going to add to that when I take the 3, I'll do that in a different color, 3 times all that stuff. So that would give me plus 3x cubed minus 9x squared minus 3x plus 3. And then, of course, don't forget your remainder, right? The plus 1 at the end. So if I add all that stuff up, there's no other x to the 4th. Notice the x cubes go away, which is good because our original term, our dividend did not have an x cubed. That would be minus 10x squareds. Add those together, it'd be negative 2x, and then 3 plus 1 is plus 4. So there is our original dividend back again. So don't be afraid of the check. There is another way to check. This is covered in sections 5.7, which we don't cover in the class, but it is a nice thing called synthetic division. It's very quick, it's simple. Once you know the technique, it doesn't take much time at all. It's just you have to take the time to learn a new technique. So if you're not interested in learning a new technique, then you can just stop this video now. If you are curious about this check by synthetic division, here's how it works. The first thing is that you really need to be careful about what your divisor is. Divisors like this are perfect for synthetic division. All you have to ask yourself is what would be the 0? What would make this expression 0? And the answer is x equals negative 3. So you're going to take negative 3 and you're going to put it in a box just like this in the corner. All right, then you are going to take the coefficients from each of the terms in your polynomial. So x to the 4th had a coefficient of 1. There was no x to the 3rd, so that's a 0. X squared is negative 10. The x is negative 2, and then your final is positive 4. So you're going to put those coefficients only of your polynomial where every term is presented. All right, and then you're going to put a line like this. And what you're going to do is you're going to bring down this one. You're going to multiply it by the negative 3. So that would give me negative 3 times 1 is negative 3. And you're going to move it here. And then you're going to add these two together, which would give you negative 3. And then again, multiply. Negative 3 times negative 3 is positive 9. And then you're going to add those two numbers together, and that's negative 1. Negative 3 times negative 1 would give you positive 3. And then you're going to add those two together. And then negative 3 times positive 1 is negative 3. And then you're going to add those two together, and that gives you 1. All right, so let me explain what these numbers down here at the bottom are. So this number right here at the end, this is your remainder. So did we have a remainder of 1 in the original problem? Yes, we did. So there's my remainder. And these right here are going to be the leading coefficients. Those are the coefficients of all the terms in the quotient. So, and it's always going to be 1 degree less. So we started with x to the 4th. We're taking out an x. So this should be x cubed. So that's 1x cubed minus 3x squared minus 1x plus 1. Double check, was that your quotient? Indeed it was. So here's your quotient. There's your remainder. So that'd be plus 1 over x plus 3. So that should have been my answer. All of that together. So synthetic division is a nice little thing. If you're curious, just go on to YouTube, type in synthetic division. You're going to see about 20,000 videos that talk about it. But this is just another option for checking that goes by very quickly. You will use this a lot if you take calculus. Synthetic division will be one of your best friends because you don't want to have to do long division for everything because it's long. Synthetic is just a bit shorter and it makes me happy. All right, so that is the end of Chapter 5. Thank you so much, and good luck on your test, and we'll see you back here for Chapter 6.